right, good morning. Sounds like the microphone's working. Thank you so much for coming here at 10 o'clock Friday morning. Did everybody have a good party last night? Yeah. Did you play dodgeball? Yeah. Did you watch dodgeball? Yes. For how many of you was it your first time at the Dev Summit party seeing dodgeball? Crazy, huh? It's an institution, you have to go. I did not play dodgeball. I watched dodgeball.
I did not watch it either.
Tanu, all right. We can't save Tanu. My name is Philip Heede. I'm a ArcGIS Enterprise Product Manager, and with me I have Tanu, who never knows how he wants me to introduce him. Mapping team, huh?
I'm in a mapping team, yes.
Tanu is very good at drawing stuff on maps.
Like, I have a gray area. I live in the mapping team, work for the server, so it's kind of grayish and pro, so.
Tanu does a little bit of everything. It's good.
I guess.
So that's why we're here together, actually. You can work with maps, obviously, in the desktop, but you can also publish them to the server, to ArcGIS Enterprise. I've been telling people all week why I had to rename the product, but we're not going to get into that here today. So we're here to talk about the million points on a map problem.
Hold on, I have a question for you.
Wait, what?
Yeah, so if I were to ask you how to draw millions of points, what is the shortest answer that you can possibly give to me?
Well, don't.
Anyone else here? No? No one? So what is that answer you have?
Well, don't draw them because
exactly.
What does this picture tell you?
No one?
There's a lot of points on this map, right? So what would my answer be from the ArcGIS Enterprise side?
I don't know.
I want some geoanalytics.
Ah.
But that's not why we're here. We're here to talk about how to work with large data sets, large in the sense of this probably is not where you want to be. You want to do something different. You want to aggregate it into some kind of geography, whether artificial or standardized geographies. And we'll take you through some tips and tricks for how you can do that with data sets that doesn't quite get to the level of necessarily geoanalytics, although that may also be an option. So here we're simply using traditional RDBMSs, traditional databases, and some advanced techniques within Pro, primarily today. Will you show us ArcMap?
Yeah.
ArcMap. Have you seen ArcMap this week? Not a whole lot. We know it's still there, it's okay.
Do you still use it? How many of you use ArcMap?
How many of you use Pro?
Yeah.
Very good.
Pretty good.
Very good.
I'm impressed by myself.
All right. Tanu is going to show us a hot off the presses internal daily build of Pro 2.0. It looks virtually like 1.4, right? At this point.
Yes, it is. And it's the technique that I'll be showing, it's available in 1.4 as well.
All right.
It's nothing new to old.
Right. So don't worry. We'll show you stuff that you can do today. You don't have to wait. This is not the road ahead session. Jay did that yesterday for Enterprise, hiding out up there. This is all real. You can do it using standard tools and shipping software. So let's get started with that. So rather than saying, how do you draw a million points in the most efficient manner and saying, don't do it, we will talk about how you can go from the million points to something like this. Maybe that's what you want, maybe not. If it's not, then, well, we'll show you a couple of other options as well. So we'll be doing a bit of talking. I'll go through some concepts, and then Tanu will show us how to actually do this in practice. Live demos. Tanu, is your server warmed up? Your database?
I believe so, but we'll figure that out, because every time I try to do a live demo, it always fails for me. I don't know. In practice, it always works.
So cut Tanu some slack when his database needs to warm up a little bit and load stuff into memory, but restart everything now, okay? We've done this before. All right, so the first thing we want to talk about is taking point features and aggregating them into artificial bins like the hexagons that we just saw. The hex bins are things that you can create yourself within ArcMap or ArcGIS Pro using a couple of GP tools. So this is about you taking and creating an artificial geography of a certain size that is appropriate for your data set. Now, what's appropriate for their data set, Tanu? You keep turning off your mic.
I don't know, because if I say something, I don't want to say it in the hot mic.
What's an appropriate size?
Size of the feature with the points?
For your artificial bins?
It depends on the size of the country or the location that you are looking at, right?
Right.
The study area. Yep.
So it depends on how close your data is together. It depends on your study area. Are you looking at a small city, a state, a county, whatever it is? And it's going to be up to you to figure out what that appropriate size geography is. That's not something we do within the software today. So you're probably also going to have to experiment a little bit with this. But once you have it, you generate those geographies, and we'll talk about how to aggregate into bins. Now, GeoAnalytics does this too, Tanu. So why should we use these techniques as opposed to something cool and snazzy like GeoAnalytics?
If you don't have geoanalytics, maybe?
Not everybody has GeoAnalytics.
Yeah.
Fair enough. Like I mentioned, this is about using tools and software that you already have available, and you can get pretty far with that for the smaller end of the spectrum of what I would say is big data. So we'll work with a few million features, I believe, here today.
Don't reveal that information at this point.
Sorry.
Do not do that.
Lips are sealed. Once we go from points to these different geographies, now we can start showing bins with counts. Maybe we're summing attribute values. There's lots of different things you can do here. So we'll go through 3 different scenarios. We'll talk about aggregating into artificial bins, the hexagon bins that we just saw. We'll talk about aggregating into standardized geographies. So by standardized geographies, I mean things like US Census blocks here in the US. Internationally, it might be districts or states or counties, whatever geographies make sense and that you have data for. Often, demographic data of various types are found for these kinds of standardized geographies. And then the last scenario we'll take a look at is working with large time series data. So imagine you have some features and then you have large tabular data that's associated with those features. At the end of the day, my primary goal, I think this is one of the best cool new features, is introducing you to the parameterized query layer functionality that is part of ArcGIS Pro 1.4, so shipped here in January, and also available when you publish those layers to ArcGIS Enterprise 10.5. So this is brand new functionality, something you were not able to do previously, and we'll take a look at that. So, all right, without further ado, let's move on to the spatial aggregation of bins. So why do we aggregate? Well, sometimes the raw data is just too much to look at. Nobody gets any value out of looking at the image we had here in the beginning, shown here in small, other than to say, well, there's obviously a lot of data. Or maybe I just made my points a little bit too big on the map. But there's certainly a lot of points on here. But as soon as we go from the raw data to something like bins, whether rectangular bins, we can start to see patterns. We can certainly see the density is completely different than just looking at the raw points here. So whether you want to use rectangular bins or hex bins is really up to you. There's a little bit of a cartographic choice to be made, but it's something that you can decide. Bins are simply polygons that you create for the purpose of your analysis, right? They're not based on pre-existing geographies, any natural features, lakes, mountains, or political boundaries. It's creating an arbitrary framework on top of real geography. So you want to consider the shape. Rectangular polygons are fairly obvious, but they have a tendency to distort the data. The distance from the edge to the center varies greatly across the bin. For some types of data, that's just not a very good choice. So hex bins is a very popular choice that we see very often these days. In fact, you see it in all of our stuff from Esri. We have a tendency to use a lot of hexagons. We love hex bins.
We love them.
All right. Hex bins also have the advantage that they're so-called tessellating shapes. So you can create a grid without gaps. There's lots of advantages here. They also look nice.
Yeah, the reason it looks like is Ken Field, he told me, and us, right? That's because all the corners from the center of the hex beams are the same distance, equal distance. That's why it's eye-pleasing rather than rectangles.
So when you're creating your bins, let's see if I can get this thing to change. There. You will want to create multiple levels of bins. It's not just about creating one set of bins, let's say a 1 kilometer, 2 kilometer, 1 mile, whatever your distance of choice is. You'll want to create multiple levels so you can look at things at, in this case, a US domestic level. Zooming in a little bit further, breaking apart those bins into smaller ones as you get closer and closer. We can start to see the different densities break apart into smaller areas. So this is again where you will have to do some work to figure out what is the appropriate size at each one of these different scale levels. When you're doing this, you're probably much more of a geographer than I am, but I was told to remember to always use an equal area projection.
That's right.
Is it wrong if I don't do that?
Yes, because you're comparing one hex bin with another hex bin. So if one size says it's 1 kilometer, 1 square kilometer versus another one is 10 square kilometers.
So now we're back to the distortion and making sure that we're comparing apples to apples.
Yes.
Excellent. All right. So use an equal area projection. I got the bullet point right.
Yay.
We give out the slides so people know and remember. All right. So, Tanu, can you show us how to create hex bins? What do we have tools for this? Do I sit and digitize little bins for myself, or how does this work?
Probably we'll start digitizing it today.
We'll start digitizing now, and by the end we'll get there.
We'll be done. Yeah.
All right.
Can you switch me?
All right.
Number 3. All right. So you're looking at the same map that Philip showed you earlier. So can anyone guess how many points I have there?
Ooh.
Yeah. What? Yes.
I don't know.
Oh, you don't know. I thought you knew it. No, there are only 60,000. Yeah, go ahead.
10 million.
You're wrong. It's only 60,000. Imagine you have 10 million points over there. So even though the discussion of this, or the title of this tech session is millions of points, I'm just using it 60,000 to show you how horrible it is. Think about 10 millions. And also to make it manageable so that I can do the demo live here. Okay, so what you asked me to do is to go from here, what you're seeing, to here, right? That's our goal. So the solution is very simple, right? All we have to do is to find out how many points we have in the cell, right? 1, 2, 3, 4, 5, right? We have that. And then I will select it, open the table, and I would add that 5 in that attribute value of that hex bins, right? Okay, there are like 1,561 hex bins I have. So could you do me a favor?
I'll write a Python script. Is that cheating?
That was a cheating. I wanted you to actually start from the upper left corner, and I will start from the lower left, bottom left corner, right corner, to the bottom. And we have like 100 folks here. They could give us a hand, and we can finish at 1 hour.
Fair enough.
No? You guys don't want to do that? Why?
They're programmed.
Come on, this is called tech session, right? We need to get hands-on. Literally. Okay, you're absolutely right. So, now that you guys don't want to help out, I had plan B, which is, as you mentioned, Python or geoprocessing tools.
Wait, you
My
already
favorite.
wrote the Python tool?
I already did. No, not Python, geoprocessing tool. So we'll take advantage of some of the tools and we'll create them, all right? So let's walk one step at a time. So this is my tool. The first thing I would do is that I would create those hex bins. So luckily there is a tool called create tessellation. I really don't remember where that tool lives. So what I usually do, I go to the geoprocessing, search for tools, and search by hexagon.
What's the application you're using here?
ArcMap. Have you forgot?
Oh, that's right.
All right.
It's been a while.
I'm old school. All right. So, and this tool lives in data management tools under the sampling tool sets. That's called generate tessellation. Let's get back there. So let's take a look at some of the properties that I'm selecting there. Oh, it's not this. Open. So it's just the name of that output feature class, the extent, and then this is the most important thing is to pick a choice, pick a shape type, and the size. This is basically in square meter. I'm saying I want an 80 square kilometer size hex bins. That's it. I'm running it right now. It will take a few seconds to add them. There you go. Now if I zoom back to United States, you'll see that it creates those hex bins for a rectangular area. Let's not show them. Right. So the next step would be to remove the ones that are outside of United States. What I will do, I will use the select layer by location, and then export that selected features into another feature table, feature class or feature layer. So now what I have is the one that on the layer that contains only hex bins that are intersected by United States boundary. All right. The next step is very simple, the one that we wanted to do by hand, right? So the next line, what you'll do is that it will run some geoprocessing tool that will go through each point, find out which hex bin it belongs to, right? Get the ID of that hex bin and assign to that point as an additional property. So if I go back to my same location and click on one of the points, I see that the point has an attribute at the bottom. It says the grid ID y-25. So it is assigned that grid ID, which grid ID it belongs to. Now if I open that attribute table and sort that by this grid ID, obviously we'll see that multiple records having the same ID. Not now, because those are outside for some reason. Okay, so these are these are all belong to the same ID called AH-32. The next step is I need to find out how many records belong to that, have the same code AH-32, right? So that's where I'll be using summary statistics tool. That does exactly the same thing. It goes through the table, entire table, it finds out how many features or records belong to the same, has the same value, and creates an attribute table. So this is the table that's generated, and this has one record for each hex bins, and that counts, that shows how many records we had in that table with the same value called AH-11, right? So now we're almost done. All we have to do is to take it and put it to my hex bin boundaries. For that one, I'll be using a joint field geoprocessing tool. That is exactly the same thing. It takes that information and put that in another feature layer. So now if I click on that one, now I say that the grid ID is y-25 and there are 64 points in it, right? So without taking any help from you guys, I did that less than 2 minutes? No. Okay, no? All right, okay. I just wanted to brag about myself. All right, so done. The last step is just running symbology, apply symbology GP tool to nicely draw that feature, right? If I go back, remove those features for a second. That table gone. I go back to my US scale. Now you see the nice looking hex bins with that information, and you can see the trend. You can see those Midwest is the tornado valley of the United States, right? So that's I'm done it at the USA scale. So if I keep zooming in, what will happen is just keep growing. It will get bigger and bigger, right? And you will see that you will not see the detail information. That's what Philip mentioned, that you need to create multiple levels of the same thing and have the same information done for multiple levels of hex bins. So that's what I exactly did. In my other data frame, I have those layers created. I'll just paste my new layer that I just created here, and then what I will do, I'll just set the scale dependency so that when I'll zoom in, that layer will not be drawn. Do not draw it when zoomed in. Something like that. So as I zoom in, you see that I'm switching from one level of hex bins to another, and again it's slow. I don't know why it's slow. Okay, now if I keep zooming in, I'm switching from from 40 kilometer hex bins to 20 kilometer hex bin. And if I keep zooming in, now it will show those individual points, because now I can actually see those individual points distinctly and see the relationship between them. Okay, so I'm done with authoring my map. The next step is to publish it. So you go through the same process, share as service, and you go through the publishing process and publish as a map service, which I already did. If I go back to my web app, so you will see the same map that I produced in ArcMap and have the same experience. I zoom in and I see it switching from one level of details of hex bins to another detail. And as I zoomed further enough, then I see individual points. Okay, so you got that? So that's how I did it, less than 10 minutes. Would that be okay, fair enough?
Pretty good.
All right, back to you, Philip.
Nice. So what we saw here was two different things. One was the idea of using artificial geographies, using those hex bins to aggregate into. The other was pre-cooking all of this, right? What Tanu did was take a static data set and aggregate ahead of time. So now all of that information was stored on the individual bins as we were drawing it. Nothing of this was happening dynamically. So that can be appropriate if you have a data set that doesn't change very often. Maybe you only get new data every month, maybe it's only every year, whatever it is for you. When you get that new data set, you can take it in, do some pre-processing, and then publish your results out. The next thing we want to take a look at is using standardized geographies, what I mentioned before, as well as start to work with data that's changing on the fly. We get new data on a daily basis, maybe weekly basis, and we don't want to go through that whole pre-processing step. So let's first talk a bit about using standardized geographies. The idea behind standardized geographies is that often when you receive data, it's already associated with an existing, let's say, political or statistical geography. Countries, like our South African example here, often have multiple levels of political subdivisions. You can look at the country as a whole, but then you can start breaking it into provinces and districts within those provinces. If the data that you're receiving is associated with such an existing geography, that's very often the appropriate thing to start drawing at. In the United States, I mentioned before, a very typical political subdivision is something like the individual states or counties, but it's often common to also see data at a statistical geography, an artificial geography that has nonetheless been defined by the US Census Bureau. So we're looking at things like census tracts, census blocks, or block groups. Sometimes you might also see data coming in at something like a zip code or a postal code. Lots of things that we see out there. Like with artificial geographies, the level of the standardized geography you'll use depends on your data, and you may have things that aggregates up to other things. So counties are typically aggregated up into something like the states, because counties are fully contained within a state, they don't cross over. One tip to keep in mind here is to not necessarily use the most detailed polygons you can possibly get your hands on. Because when you're doing that aggregation, the coastline of South Africa, for example, has quite a few vertices if you get the most detailed version possible. And that just takes a lot longer. So if you can do your aggregation using a more generalized set of polygons, that can speed up your process quite significantly. The example here locally is the coastline of California. California gets pretty gnarly when you start digitizing. Tanu did that by hand once, right?
I did that.
No?
I did that, yes. That's where I got my gray hair.
So, that's good. That's a new one. The idea behind using a more generalized set of polygons really matters when we start doing this on the fly. Right? If we're doing it as a pre-processing step, it may not matter too much if it takes a bit longer, but when you're doing this on the fly and the ArcMap Pro or the server, if it's been published out as a service, has to do all this aggregation, then you certainly want it to work really, really quickly. So as we move on here, it's also important to use the right level. We have tornado data here, and in this case, I'm showing the tornado data aggregated up to the state level. So looking at this map, where does it look like we have the most tornadoes? Texas. Now, strictly speaking, that is true. There are more tornadoes in Texas than in any other state. What's also true about Texas, though? It's a very, very big state, right? We're not comparing apples to apples. So using that right level of geography to aggregate to, if we break it apart into counties, we get a very different picture. It's easy to lie with statistics, right? This is the exact same data aggregated to two completely different sets of geographies. And when we look at this, we can see that we're somewhere in the Midwest. Is that Colorado? That seems like an odd place.
Something like that.
That's where all of a sudden we have a lot of tornadoes. So when somebody tells you, don't move to Texas, you don't want to get hit by tornadoes, well, it just so happens there's a few places in Texas, but it's a very big state, so it's too broad of a statement. It's very misleading.
Move to California and hit by earthquake.
It's trade-offs to everything, Tanu.
Yeah.
So when we look here, we can see that it's the northeastern corner of Colorado, I believe, and then down in Florida, we actually have a lot of tornadoes. Texas is simply so large that it dominates. So selecting the appropriate level of geographies. Something to keep in mind, even when we talk about quote unquote an appropriate level, is that for something like counties in the US, you still have to be a little bit careful. You're not comparing apples to apples, even when you're looking at counties, because they do also vary in size. In the US, counties on the East Coast have a tendency to be much smaller than counties on the West Coast. San Bernardino County, where Redlands is the largest county in the US by area. So all of a sudden, we need to be careful about looking across the map, but at least it's a lot better than looking at the state level here. So I mentioned the different types of aggregation approaches. We saw the pre-calculated approach before with Tanu's. It gives you faster drawing speed. There's some upfront processing, and it's good for when you have data that doesn't change very often. But doing on the fly gives you a lot more flexibility. As data comes in, you can simply add it to the underlying data set, and it'll immediately show up within the map service if you publish it out. And it can be good for data that for that reason does change often. Of course, there's trade-offs. It doesn't draw as fast. That's why we have to warm up your map service every now and again, right?
Mm-hmm, mm-hmm.
SQL Server, getting all this stuff in.
Feed coffee to my map service.
Is that what it is? Okay. So we want to move to the on-the-fly approach and talk a bit about the different options there. We saw the geoprocessing tools that Tanu used for doing the pre-calculated aggregation. But in many cases, you can also do this simply at the database level itself, right? You guys are all programmers. It's the dev zone.
Yeah.
We've done a similar presentation at the user conference. People got a little bit scared by the SQL. I trust that you guys are not scared by SQL statements.
I haven't seen any face here looking scared. I see someone ducked there somewhere in the back, but other
I saw somebody look at the colored box and they were like, no, I'm done, no colored boxes. We should have shown the SQL earlier on. In this case, we're using a spatial SQL statement from, I think this is SQL Server. Yep, that's SQL Server. And of course, there's lots of different ways to do spatial SQL, whether it's SQL Server, Postgres, Oracle. There's lots of different spatial options in the databases these days. We'll be focusing on the more general approach here, the generic approach that works no matter what underlying database you have, because all of them are slightly different. They all use the similar ST geometry or spatial types, but nonetheless, we'll focus on what's ArcGIS generic, so we can do everything no matter what our underlying tools are. So a key tool that we'll use is the spatial join tool, of course, and then summary statistics that we saw Tanu use here just before. So we'll see Tanu do more magic, right?
The database. I will take the credits.
Wait,
the database does that.
You're going to do You're going to do SQL?
Uh-huh.
Crazy.
Yeah.
All right, let's talk about that. So on-the-fly aggregation in ArcMap is based on query layer support. So query layers have been around for quite a few releases now. I think 10.0.
10.0.
So there's no version in existence today that doesn't have query layers. Nobody uses 9x, right?
Anyone?
I always like to do a little bit of a, like there's the one guy in the back.
There is one guy who's still not using 9x?
ArcMap 9x. I
like it.
I really like 9.3.1, I have to admit. That's a good release.
Actually, 8.3 was the first one that I moved to, switch completely from ArcView to ArcGIS 8.3.
Now you're dating yourself, Tanu. So in ArcMap, you can create a query layer in a couple of different ways, but the simplest approach, at least in my mind, is simply file, add data, and then the add query layer option here. The query layer option brings up a dialog where you can connect to your database and you can work with your fields. And basically, this is your ability to write whatever SQL statement you want. Anything that works against the underlying database. You're, to some extent, creating a view on the fly. I like thinking of query layers as sort of a higher level view on top of the database. Within ArcGIS Pro, we of course have those same options. There's even more options within Pro, and that's what we're going to take a look at here in just a second. Within Pro, you go to the Add Data menu. There's a query layer option just like in ArcMap, but we have some new cool things that just came in with Pro 1.4. You now have the ability to add parameters to your query layer, meaning you can inject new different parts to the query on the fly. For example, if you have a time field on your data, now all of a sudden you can start doing averages and doing some of those aggregations within the specific time period that you're specifying. Instead of creating the average on top of the entire data set, just for this 1 week, what's the average within that 1 week? That's a really, really cool, interesting new feature.
Yep.
Do you want to show us?
Yeah.
Awesome.
We'll go over that. All right, so I have to admit one thing that you tried to scare me with the number of points and map server is being slow with aggregating it. Actually, I was joking at that point. I tried with millions of points, millions of records, and it was really super fast. I tried with the 43 millions, so it's doing good. And other thing is that the also trick is to have that spatial relationship done up front. So that it will only attribute joins, so you'll be all fast.
Now we're getting to the advanced techniques
Yes.
portion of the session.
Yes.
Awesome.
Right. So what you said that that when the data gets changed often, then you need to use some other techniques. You cannot pre-compute the value. Also, it's true when you are as a scientist or some analyst, you will want to look back in your data and try to see some pattern. Like we saw that same thing before, right? In my previous demo in ArcMap and Map Server, but it was pre-computed. But what if I want to do like this? I want to see my result aggregated for each decade, but when I use my time slider, it will move by 1 year at a time. So every time I move, I get a new data set computed for the 1 decade and move on. So that I can, if I want to see some trend, like is the number of tornado hit USA is increased over the time. You will actually see that pattern. See, it was mostly greenish before, now it is turning to yellowish, and you will see more red and yellow as we get to 2000-ish area. See that? So this what helps you. It's not just that 1 year. I mean, if I want to, okay, it's more greenish, now it's more reddish or yellowish, purple, orangish. Or you can change that to any time window and see that, right? Oh, that was like from 1976 to 2010. That's why. Don't worry about that. Okay, it's not going to hit you today. So that's one, right? And the same time, when I do that, I want to do exactly what we had before. I want to play my animation, but as I zoom in, I want to switch to one level of hex bins to another level of hex bins. See that? I want to do the similar experience, but I want to do that on the fly aggregation. That's one. How about the one that Philip mentioned about if I want to do that for known geography, right? What is that zoom to layer go? There you go. I can do that for states. Same thing. I can move to any time window, and I want to know how many tornado hit that particular states in that period of time, right? So if I label them, you'll probably see it much nicely. So if I go from one to another one, there you go. The number of tornado hit that period changes, so I can see my maps change with the features being drawn with a different color, as well as I can see the labels.
All right, Tanu, I want to see some SQL statements. Like, I'm not sure I believe all this.
You don't? So you want me to
I've seen
create
your
something?
demos before.
So you think these are PowerPoints?
Very elaborate set of PowerPoints, I will say.
All right. I will take your challenge now. All right, let's switch gear and look at the SQL.
Oh, good.
All right. Okay, so you guys are SQL expert. I don't have to show it, but since it gets recorded, and if someone else look at it who doesn't know much of the SQL, that's why we are presenting it right now. So the idea is that database, you have this query that I want to know how many tornadoes happened there. I want to know the total loss we had using the sum for my entire data set. Right? If I run that, there you go. I got one record back that shows me the total number of tornadoes. That was 59,847. Total loss was something millions of dollars.
So this is across the entire time period, your entire data set.
Entire data set for the entire United States. Yes.
Very interesting.
No. What you want to do is that you want to do that by the state. So all you have to do is to have them group by, right? This is the one. So the same query that I had before, all I have to do is to add the group by and add that state fibs on the top as in the select statement. That's it. Okay, so now I got my result, but where's the geometry? Geometry comes from another table, on that table with the spatial column in it, or feature class, as we know from our ArcGIS world. So that's what I'm doing the next one. So I'm taking the exact same query, now I'm putting that as an inner query to a join. This is the outside query. It's joined by the state fibs. Once I run that, now I'm getting the result back I had before, but this time with the geometry in it.
I basically don't even need ArcGIS Enterprise or anything. It's like the SQL Server Management Studio, you can draw maps.
Is that a pretty map? Do you look that? Do you like it?
All right, fine.
Does it have a time slider?
Fine.
No, there you go. All right. I got you there. All right, so that's cool. That's for the entire data set. As mentioned, from 1950 to 2014, probably that's how long that data I have. Now, if I want to do that for one particular time period, for the 10 years from 1990 to 2000, all I have to do is to add this where clause in my query, right? So there's just a where clause. That's it. So now that I have it done here, okay, I can execute it. You see the result. All I have to do is to go back to Pro. I'll start from the brand new map. No PowerPoints again. And hopefully it will not crash right now.
Well, just say it's because you're using a daily build.
Yeah.
Don't worry about it.
Another thing always happens to me. I don't know why. Anyways, I added my new map. I go to my map tab. There is an add data menu, drop-down menu that you saw on the slide. There's a query layer option. All I have to do is make the connection to my database. I'll provide a name called states, tornado by states. I paste it. I'm done. You can see. All right. Is it the same query? I have it. Now I have to go validate the result. Few things I have to pick is that object ID, which is by default, it picks one for you. If it cannot pick, then you have to pick a field or more than one field to define unique values, but I would not recommend you to use more than one field because it has a performance issue too. And then it gives you some of the information of the geometry, right? It picks the geometry and see what projection system it is in and etc. I'm done. I added my layer. There you go. I have it.
It's a terrible map.
What do you want with that map now?
It's just green.
Oh, you don't like green map? Okay. All right, I'll change that to unclass renderer. Will that help?
Fair
and
enough.
Use that instead of state fibs, I will use the total tornado. How about that? Now it's good?
All right, you're getting somewhere.
Cool. So now what we're looking at right now is that we're looking at the total number of tornadoes by state, okay, 1990 to 2000, right? So now if I want to change that to something else, like first of all, I don't have the time slider here. Where did the time slider go? And if I want to change that to some other time, how can I do that? That's where the new thing come into, that new aggregate, we use the parameterized query. That's where the things, that's where you can use the parameterized query. So I'll go back to my source. I'll make it larger. All right. So all I will do, I'll just remove this piece and make it parameterized by use a special secret code called : R:. If you forget about this one, which I always do, okay, because I have a cheat sheet here, right here. So all you can do, just click that link here. It will open up the help. Whenever you, there you go. And then you can get that information from there. So help is right there on that dialog box. So now I'll put a variable name called time var. Once I'm done, I have to provide some information to that variable. Right? I declared my variable, and then I have to put some metadata information for that variable by clicking on that pencil side. So first thing is that what is the field I had before in my work class? I had field called DT. You guys see it, right? Okay. And what is the data type, the output data type, or the data type I have in that field? I pick a date. I can specify default value if I want to. If I don't, like in the case when I really have the 50 million records in my table, I would rather use some default values in case someone actually disabled the time slider. So I really don't want to have the database to scan through entire 50 million records and aggregate that. That will bring your database to its knees. So you shouldn't do that. So I'm done with it. Validate the result. I'm good. Click finish. Go through the same process. Now, the moment I did that, if I go back to my time tab, you see that it's already know that this layer is time aware. It made that available. It computed the full time extent from that database, and you're ready to go. If I click OK, the time slider shows up right there. I enable my time slider. I go to any time window I want to go to, and there you go. I see my result.
That's pretty cool.
Okay.
I'm pretty impressed at this point.
Now
I have to admit. How long did it take you to develop this parameterized query thing?
In one release, we did that. In 1.4, that is like, was that 3 months or 4 months?
I've been asking for it for a while.
Don't tell anyone I did that too.
Did you cook up the whole : R thing?
Now actually it's Brijesh. He did that. He came up with
We know
that
who to
idea.
blame. That's fine.
So there you go. Now you have that. Now if I go back to my any symbolizer and you see that it has other fields, like we ask the database to compute the total tornadoes, total crop loss, total loss, anything. I can use any of them, and I can dynamically compute the result and see my map right there, right now. Okay. So is that only thing that you can convert always points to polygons? Not always. I have a surprise for you. So this is the points data. Okay. So it's a time and aware point data, right? I can tell you the secret. This is just a flight record information.
I love flight data.
So if I play it, it shows where are those, but doesn't give you much information, right? What if I want to know the flight path that will be computed on the fly and show me the last position of those planes? And not only that one, I want to show them with the beans. So as the flight moves into one bean, it will appear and show the number of counts of the planes in that bean. And as they go away from there, it disappears.
But how much data do you have there?
This one is not much, but I was planning to do 40 million records. I'll do that, and I'll let you know.
You're gonna steal my demo?
I will.
And do it in Pro?
And give it to you.
No. All right.
So that's cool. So bottom line is that you have points, a record or something, and you don't want to show all the points at one point, even though again, going back to the text session name is draw millions of points, but we are not drawing millions of points because doesn't make any sense. So you can do, as you mentioned before, you can pre-compute that, or you can do on the fly. On the fly is probably most appropriate in many cases when you do analyze or something like that. Back to you.
So no matter what application you're using, whether it's ArcMap or Pro, a couple of things that I would highlight from what Tanu just showed us. It's really important to have proper database indices, right? We're pushing all of this down to the database. If you have millions of records, you're not going to be doing full table scans and getting great performance. If you're the DBA, you need to look at what is the SQL statement that you're putting together. Is your query optimized properly? Are you joining on the right fields? Are you doing all the right things there? And have I defined my database indices? That's key. You will truly, like Tanu said, bring your database to its knees if you don't do this right. So it can take a bit of work and multiple attempts to create your query. So focus on correctness, of course. You want the right data to show up, but also choosing the correct join and other things there. And once you're done, you can stay in Pro like Tanu was doing here, but of course you can publish that out.
Yes.
So the server can create a map service out of this just like anything else. There's nothing magical about query layers that means that they're limited in some way. All right. We want to get to one last demo, time series data. We have a couple of different examples. So imagine rainfall data. You have a static point. This is where we're collecting information about how much rain is falling down. That station, that weather station doesn't move. What does change, of course, is the attribute values associated with those weather stations as water does or does not come down. Here in California, we had 5 years of rain not coming down. That has changed. We now have plenty of water. So 1,000 weather stations reporting once per day for 10 years would give us over 3.5 million records. So 3.5 million records is a decent amount of data. And that's something that we could work with and do similar things to what we just saw with Tanu. The specific example we're going to take a look at here now is stream data. Similar in the sense that, well, streams generally don't move too much. It does happen. Natural erosion and stuff moving. But for the most part, we can consider them fairly static. So we have lines. And in this case, we're trying to predict how much water will be flowing in a stream based on rain falling somewhere and then going downstream over time. So our example here is 67,000 stream segments, and we're trying to predict in 4-hour intervals over a 10-day period, meaning we're creating 4 million records. So this is tabular data. Associated with the stream, we are generating 4 million records of this particular segment. We'll have this much water flowing through it over this period for the next week and a half. In this case, the interesting part is that it's tabular, right? Now we want to join a separate table, no spatial attributes, to that something else. All right, so setting up the data is a multi-step process. First of all, it's a one-to-many join, right? We have one stream segment joined to many different values out in the future, those 4-hour intervals over the next week and a half. When you do this, you want to make sure that all the data comes from the same database. This is a really important point because within ArcGIS, we make it easy to join data across many different data sources. And that's really nice when you're doing a little bit of ad hoc exploratory analysis. But again, if this is something you're publishing out as a service for others to consume, you don't want that join to happen client-side, the server having to pull all the data from multiple different data sources and then stitch it together. You want to make sure that you can push as much down to the database. And that means you want to have all your data sources or all your data sets in that single database. And again, you want your indices to be set up properly. Whatever you're joining on between your spatial data and your tabular data, make sure that that lines up so you get the best performance possible. Now, some other new things with Pro is display filters. I don't think I want to try to explain that one because it's much easier to see in practice. So you're going to show us that as well, right?
Yes.
Nice, you've done your homework on this.
Shh, don't tell it to anyone.
That's good. That's not a bad thing. Display filters is a new feature, and Tanu will show exactly what that means for you. It's a way to simplify what your map looks like in Pro as well as in the resulting services. So using display filters to essentially set up scale dependencies, making sure that you don't necessarily show every single stream segment, in this case 60,000 stream segments when we're zoomed out to the US. So the way to do that in old school ArcMap and Pro prior to Pro 1.4 was typically to add one layer at a time, right? Multiple different layers in your map with different scale dependencies. And then we filter out bits and pieces of the underlying data at each level, similar to what we saw before where we were generating multiple levels of artificial bins, right? We change what we show at different scales. New at Pro 1.4 is this idea of display filters, which actually allows us to do just one single layer. So let's take a look at that.
Okay. Cool. All right, so again, looking at this map, doesn't give you any idea information, right? It's just a big blob of blue on top of the black background.
It's kind of pretty.
Cool, right?
I like blue. I like blue on top of the dark base map.
I like too, but
Flights,
does it give you any
like that.
information?
Right.
Do you see anything there? Can you even see those individual streams or rivers?
Guess
no,
not.
Right. So again, this is the stream layer that I have, which has actually 74,767 features.
You added more streams since I created the slides.
Yes, I did. I'm trying to hide something from you. Okay. Anyways, that has, and this one, just that information about those, this has a location, ID, and the stream level, order, some of the length, etc. No other information. But the model data that we got, as you mentioned, that has about, 4 million records in it. Okay. So now we're getting to the million business.
Finally. We've got like 9 minutes left, Tanu.
Oh, we can do that. We can do that.
But with 9 minutes left, you finally
We have
showed
100,
millions.
we have plus 100 people again. With their help, we can do it.
Okay.
All right.
I'll take from 0 to 1,000 and
Go there. Okay, and there, as Philip mentioned, is a one-to-many relationship. You see the ID are the same. It's just the data that we are getting from that model output. It has different. These are the water. Would discharge the amount of water that they're forecasted to flow through that river or the stream segment at that given time period. So that's the information that we have. Okay. What we'd like to do is to come up with something. Now it looks a little better, right? Because now you can see the river, and if I use my time slider, now you say that how the waters is moving are forecasted to move down the stream, right? So that's what I would like to see when I zoomed out, which is good. But as I zoom in, I would like to see detailed information. How does little branches or the little streams they are going to perform? Okay, what are the waters are coming down the stream? So that's what we'd like to know, so that I can have my information that I can make my decision upon. Should I send my crew over there? Should I be worried about the dam break or something? Right. That's where we need that information. So how do we do that? Right. So in old traditional way, of course, no. The first step is not traditional. That's how it is. It should be, as you mentioned, that it needs to be joined. Right. We have the information in another table that needs to be joined to my feature class. Right. So that's what we do in this case. For example, I have these joins done, right? In old traditional way or in the ArcMap way, then what I have to do is I have to set the definition query for each layer. I'm sorry, this is the layer at the very bottom that will draw all the streams. For anything else, I have to set a definition query so that it will filter out and show me only the streams that I want to see at that scale. Like at that scale, I want to see only the ones that are greater than or equals number 6. That's it. So I can do that. But the problem with that is that there are multiple layers here showing up in the TOC. TOC gets cluttered. And when I publish that to the web map, it becomes the same thing. It has more layers and you have to toggle them, and its user experience is not that good. So that's where we introduce something called, as you mentioned, display filter, which is a very geeky name. What is the non-geeky name would be? Do you know? It's actually basically scale-dependent definition query, right? So I have definition query. I will have multiple.
You think that's less geeky?
Scale, right. No, okay, I have to break down into small scale. Dependent is non-geeky, and then, yeah, I agree. I'm sorry. All right, let's move on. So, again, this is the one layer I have right now in the TOC. If I open my definition query, again, which is scale-dependent definition query, to do that, all I have to do is to go to the Appearance tab. There is a little thing called Display Filters. Actually, there is a good reason we call it display filter, because it actually only impacts your drawing. So if you open the attribute table, you will actually get all of them. If you select or identify, you will actually identify all of them. You can query, you will get the query result, doesn't matter where exactly you are displaying. So that's why we call it display filter.
You could say it filters your display. I like this.
Right. So I got my display filter property page open, and you see that I have multiple definition query set. Right. Each of them are collapsed. I cannot expand them, and I see that this is the one. And this is the bar that you were seeing across. Those are the scales. Okay, that means that at that scale, from wherever infinity to 1 to 15 million scale, I would like to show the features that meet this criteria. Same as here, when I'm between 5 million and 2.5 million, I would like to use this definition query. So it's gonna be happening on the fly, right? So if I zoom in right now, you see that it's honoring that scale. The definition query that I set to the display filter. And of course, since I have this time, now that I've joined it, the time information came from my other table to this table, right? And then so that I can set the time. So you guys know how to do that. You open the property page of that layer, go to the time tab, select, each feature has a single time field. I choose the time field. The time value is the name of the field that contains the date time stamp. And this is again coming from the other table. All right, I'm going to do that one. Now you can use that time slider to move from one time to another time. This is not a good area that I zoomed in. Let's zoom out. There you go. Now you can see that water is flowing down that stream. Right. As I zoom in, I'll see that small streams popping up, and I'm seeing that information too for that other branches of the stream and the small rivers coming to that. And now, which you already saw before, you can still go ahead and publish it as an image layer from Pro, right? So same publishing process, go to the sharing and publishing. And then I already showed that once you publish, you can use that in the web map and you get the same user experience.
So if you, can you open up the REST endpoint for the underlying map service? I mean, we've shown a little bit of SQL, but I feel like here with a couple of minutes left, we should show a little bit more of a dev summit type thing. Is there truly just one layer in that map service now?
I open that, and there you go.
That's pretty cool.
That is, this is the layer that I'm looking at, and this is the one layer. There's only one in the table. I just have that table there.
So now when you're creating your application, you don't have to have application level logic to also know, should I be querying or interacting with this one layer versus another? There's just one layer to work with.
Exactly.
It's pretty cool.
You're absolutely right.
It's pretty cool.
Yeah.
So Tanu, I wanted to say something.
Yeah.
Thank you, Tanu.
Me or them?
Pretty good.
But I would like to thank them for being waited so patiently and listened to me. I know it's hard.
With a couple of minutes left, you managed to show millions of, well, it wasn't points, millions of records associated with thousands of line segments.
Yes.
All right. Thank you, everybody, for coming. We really appreciate it. We don't have too much time for questions, but come down here if you have any, and we'll try to answer as best we can.